Good morning, sixth graders. Today we are learning the 3 different ways to solve any proportion that I could put in front of you. One of which you guys have done over and over and over again, whether you know it or not. And that's the first method called side to side, because that is what you have been using to find equivalent ratios and equivalent rates. It's also what you've been using to divide down into finding the unit rates. And you may not have even realized that you were using proportions. So the 3 general ways to use and solve any proportion: the first way is side to side. The second way is going up and down. And the third way, which I was a bit hesitant to teach you because it kind of involves variables and it involves a little bit of algebra, I found a way to simplify it down to where it hopefully makes sense. Okay? So without further ado, let's look at the first option of solving ratios. And that is going to be the side-to-side method. Okay? This is the one that I told you I really feel like you're going to be most comfortable with and most fluent with at this particular point in time. And if you're looking at your worksheet, it goes with number 3. This particular proportion reads 7 to 9 equals y to 18. We're having to find out, what does y equal? And what we have done in class is we have done this. Wherever you have 2 numbers together, here we have 2 numbers on the bottom because we're looking for a top number, you look at these 2 numbers and figure out, what do I do to one number to get the second number? And since our y is on the right-hand side, that means we're going to have to move left to right to fill in that gap. So you have to ask yourself, what do I do to 9 to make it become 18? The reason why they call this side to side is because you have 2 numbers on bottom or on top that you can easily change into being one another. And in this case, we are going to multiply 9 times 2 to become 18. And if I do that to the bottom, I do the same thing to the top to where my y is going to equal what? 14. Perfect. So now here's my next question for you. And I want you to think about this. Are they equivalent? Do they equal each other? The answer here is yes. Because we multiplied both the top and the bottom by 2, we did the same thing to them. All we did is make it bigger, and so they are equivalent. But now let's ask this too. Are they proportional? This is something that you're going to have to know how to do, and I'm going to show you a quick trick to do it. Write down your proportion that you've been given. We have 7 over 9 equals 14 over 18. I know in school you've heard your teachers in past years use the words, the big X. Well, in this case, to check to see if they're proportional, or in the book it may say proportionality, you are going to cross multiply. And if you get the same product when you multiply the 2 numbers, they are proportional. If you do not get the same 2 numbers, they're not. Okay? So let's look right here. And guys, I can't do this in my head, so I'm going to do a little work right here. 14 times 9 is 126. So I cross multiplied these 2 numbers. Now I'm going to cross multiply my 7 and my 18. Well, 18 times 7 is also 126. So are these 2 rates or ratios proportional? The answer is yes. That's how we do side to side. The next thing that we're going to look at is how do we do up and down? How do we do up and down? And guys, look at number 8 and number 10. That's where we're going with this one. Let me move this down a little bit more. Okay. The first problem on up and down is 1 over b equals 5 over 10. And guys, the reason why we call this up and down is because there's no real easy way to go side to side. But look at this. To be honest with you, you could go 5 divided by 5 is 1. You could do side to side on that one as well. But overall, the easiest thing to do is to look at this 5 and the 10. What do I do to the 5 to make it become a 10? I multiply it times 2. So I'm going to do the same thing to the other side, and 1 times 2 is 2. So b equals 2. Over here, guys, there is no real easy way for 14 to become 6 or 6 to become 14. But look at this. There is a quick and easy way to go up and down to make 14 become 7. And since my variable is on bottom, I want to go down. So 14 divided by 2 equals 7. So I do the exact same thing to the other side. And so h equals 6 divided by 2, which is 3. Now my question again for those two problems is, are these equivalent to each other? And the answer is yes, because on both of them, we either multiplied both sides by 2 or we divided both sides by 2. But then we're left with the question, are they proportional? Let's see if we can figure that out. Well, I have 1 over 2 equals 5 over 10. Let's cross multiply. 1 times 10 is 10. 5 times 2 is 10. So we know this one's proportional. Okay? Now let's look at the second one. 14 over 7 equals 6 over 3. Well, I'm going to cross multiply to check the products. 7 times 6 is 42. And 14 times 3 is also 42. So the answer for both of these is yes. They're not only equivalent, they're also proportional. So remember, this is where you look at the top and bottom of one of your rates and you change it and you find your rule to do to both sides. The last one that I think is probably going to be the most complicated for some of you, but for other ones of you, you're going to be like, oh my gosh, if I can figure that out, I'm like totally set. This goes with number 1. This is what I want you to know, and I'm going to put this in parentheses right here. This is a method that you can always, without fail, you can always use this method. So if you're one of those learners where you don't like having 3 different options, you just want to know this is the one best way to do it, and you can learn that one way and be consistent, this is it for you. Okay? The problem here is 7 over 6 equals, 5 over z. Well, in cross multiplying with division, this is what you do. You look at your proportion and you find 2 numbers that are across from each other, making an X. They're crisscrossed from each other. And in this particular one, we have the 5 and the 6. So I'm going to draw a circle around them. I am going to multiply them together. Then I look in my proportion and I find the only other number that's left. Not the variable, but the only other number. And that's 7. So I'm going to divide by 7. So guys, what this is going to end up looking like is 5 times 6 divided by 7. 5 times 6 is 30, and then 7 is on bottom. And y'all know it's not the best thing to leave improper fractions as your answer, so let's simplify that. That's going to come down to 7 goes into 30 4 times with 2 left over. Now, could you leave that as 4 2/7? Absolutely you can. But if you're going to check to see if they're proportional, it might be good to change it to a decimal form. And you guys have learned that to change fractions to decimals, you use top dog in the house. So if I take 2 and I divide it by 7, I'm not going to go any farther than 3 decimal places. I know that this is going to equal 4.29. So Z equals 4.29. Then ask your questions. Are they equivalent? Did we do the same thing to both sides? Well, in this sense, we didn't. They're proportional, but they're not equivalent. So in this case, if we ask if they're proportional, I would say yes, but look at what happens. If I have 30 over 7, I just wrote down the wrong thing. 7 over 6 equals 5 over 4.29. This decimal is going to throw everything off. Because do I have a decimal if I were to cross multiply the 5 and the 6? No. I would just get 30. When you multiply 7 times 4.29, you're going to get 30.03. But isn't that pretty close to just 30? Yeah. So we can say yes, it's proportional. Guys, those are the 3 different ways that you can solve proportions.